So anti-differentiation gets into the actual mathematics, the, the process itself. The first thing that we want to think of is if we know dy dx or f prime of x, and we want to find the original function of y or f of x, we're going to use the reverse process. Think about what word I always use for reversing the process, undoing in equations. I'm going to call this the inverse process of differentiation, and we just call it anti-differentiation. We're going to get in, I don't like, they're showing you that one is just the inverse of the other, the whole anti-differentiation, but we'll actually call it something different as we move along. But it's really both. All right. So the first thing to understand, I like this visual here. If you start with y or f of x, you differentiate, you get the derivative dy dx or f prime of x. If you start this way and you want to find the original function, you're doing the antiderivative or anti-differentiation. They have a lot of words that all just mean the same thing. So don't let the different types of words, whether a noun, a verb, an adjective, whatever, when you see the words, they mean the same thing. So let's think about, what if the derivative equals x squared? What would we do to find the original function? So what do you think it would be if x squared is the derivative? What was the original? What did it start out being? Let's think about maybe the degree. So if the derivative is x squared, what does the original function have to be? Does it make sense? It needs to be one more than the derivative function. The degree of the original function is always one higher than the degree of the derivative. Now, if we were to take the derivative of x to the third, do we get x squared? Well, we drop this would be 3x squared. Notice this derivative up here doesn't have that 3. So what would I do to x to the third, that if I wanted to cancel that 3 out? Does it make sense? I would just divide out that 3, because if I bring the 3 down, I get 3x squared over 3, and the 3's cancel, leaving me with x squared. Now, the other thing to keep in mind, we don't know if the original function had a constant, so we should always include a constant at the end. So we don't know what that constant is. Maybe it's 0, but we don't know, because the derivative of a constant would be 0, so you wouldn't see it. All right. So I actually have some space. Think about the process. Let me come back here. Think about the process. When we do the power rule, what do we do for the power rule? We bring that down, multiply any coefficients by that exponent, and subtract 1 from the exponent. So if I want to undo this, does it make sense in the anti-differentiation? I would reverse it. So the first thing I'm going to do is add 1 to the exponent and divide that exponent. That's where this came in, because we need to undo this process. So if the power rule is to multiply and then subtract 1, backwards we're going to add 1 and then divide. All right. I think the blue box can be a little bit extra. I'm not going to be super sold on this. Let's focus on example 3. Now, I'm going to start with, if the derivative is x to the third, what would the original function be? So think of the process, add 1 and divide. And I'm always going to put that plus c there. Add 1, divide. All right. Letter B. Y equals dy, sorry. The derivative is e to the 2x. Think about your process. What is the derivative of e? So what's your antiderivative? Well, the nice thing about e, the derivative of e would be just e. Well, what do we always have to chain on? Don't we always have to chain on, multiply by the derivative of the exponent, which is 2? So if we're going backwards, the antiderivative, instead of chaining it on with multiplication, we just divide out that exponent. Now, IB's not real focused on this plus c. I'm just saying, I think you need to keep it in mind for later. All right. Letter C. dy dx. Now, I would say we need to rewrite this. Remember, this is 1 over x to the 1/2. But we want to move this to the top. So that's going to be x to the negative 1/2. So think of the process. The antiderivative, we're going to add 1. So if I have negative 1/2 plus 1, that's a positive 1/2. Then divide out the 1/2. Well, what do we do when we divide by a fraction? Is we multiply by the reciprocal. So if I'm dividing by 1/2, I'm going to multiply by 2 plus c. So what I would always do is we're getting started with the whole antiderivative process. As soon as you get an answer, I would take the derivative and compare. So what would the derivative of this answer be? So we multiply and get 4x to the third minus 1, but the 4's cancel, and the derivative of a constant is 0. And see how these are the same? If you don't get the same answer, that's when you need to adjust. But you can always do a quick derivative of the answer you got and see if it works. So like this last one, 1/2 times 2 is just 1x to the negative 1/2. Well, isn't that what we started with? And there's some homework.